Hello, my name is Andre Paiva, and with this presentation, I'll talk about the project developed in the University of Rostock as part of the EM-Ship Plus Master in Advanced Ship Design by the student group Andre Paiva, Mirun Kanadan, Asad Khan, Laura Lungu, and Jonas Musil. The project has been submitted and awarded second place in the Worldwide Ferry Safety Association's International Student Design Competition. A set of requirements were provided to aid in the development of the design of the ferry. The route considered for the ferry operation is in the canyon part of the Lake Victoria, with the main objective to provide a reliable means of transportation to the local commerce, but also for the tourists. As a challenge, the ferry should be able to transport a wide variety of goods and vehicles with the desired capacity to transport 30 saloon-sized vehicles. Some restrictions also come from the lake infrastructure: a maximum draft limited to 2.5 meters, a maximum air draft and breadth of 8 and 40 meters due to restrictions of the Rusinga-Mbita bridge. The speed of the vessel should be enough so it will be an efficient alternative to the conventional roads. Thus, the design speed has been considered 15 knots, taking into account the accelerations and decelerations of the vessel. The main dimensions were selected according to existing vessel and with the configuration that allowed a multiple-purpose cargo configuration. The vessel length is 120 meters, 25 meters breadth, and 7.5 meters air depth. The cargo deck allowed different configurations to be achieved. In the upper picture, it is exemplified a configuration where mostly trucks are transported, and for the lower, the cargo deck has been adapted for transporting livestock, which could also be utilized to carry bulk materials, as an example. Thus, the flexibility of the cargo configuration improves the financial benefits achieved by the ferry. A hoistable intermediary deck is present in the aft part of the vessel to be utilized when a larger number of smaller vehicles are being transported. This additional feature allows a larger cargo area even when the ferry is fully loaded with leisure passengers. The main deck is fully accessible to wheelchair users. It has 2 toilet rooms, a restaurant, a bar, and a duty-free store. Also, the crew cabin and deck are restricted from passenger circulation to optimize the vessel operation. Life-saving appliances are located both in the aft and fore part of the ship to allow a quick and efficient evacuation if necessary. With the final weight estimation and center of gravity positioning, it was possible to perform final adjustments to the hull form and getting values close to the estimated. For the loaded condition, the center of buoyancy of the hull is close to the center of gravity, thus the ship operates with a very limited trim. The hull was also designed to be as simple as possible to ease the manufacturing procedure, and from the 3D model we could draw the lines plan. Once the hull form has been set, the intact stability was verified for all the criterion specified in the IS code, and for all the loading conditions the results were compliant. Considering a compartmentation with 3 longitudinal bulkheads, 1 going through the center line of the vessel, and 2 with an offset of 8.5 meters, and 11 transverse bulkheads, the probabilistic damage stability has been calculated with MaxSurf, with the attendance index being above the required, even for the partial cases. The total resistance has been obtained from a potential-based software, and estimating an efficiency of 50%, it was possible to estimate the required powering of the ship. To reduce the dimensions of the engine and the fuel consumption, the required power has been divided into 2. Thus, a Caterpillar engine compliant with IMO Tier 3 is selected with a maximum brake power of 1900 kW and with geometrical dimensions that allow the installation in the lower deck, since the maximum height of the engines will be 2.2 meters. Based on the weight of the vessel and the local economy and salaries, the price of the vessel would be around $4.5 million. To end this presentation, I would like to reinforce 3 key points of our design. The first is that we wanted it to be more than a means of transportation, with leisure activities offered to the passengers, encouraging the growth of tourism and local economy. Also, complying with the height constraint and multiple cargo configurations increase the economical viability of the project. The design also easily attends the criterion of the relevant security rules, and the simple geometry of the vessel reduces its manufacturing costs. I would like to dedicate this slide to thank the support we had from all the professors of the University of Rostock and the M Shipmaster, our family and friends, and the organizers of this competition.